All right, so now let's apply this concept of using inverse matrices to solve systems to solve a couple word problems. So here's our first one for today. 3 bands perform at a concert venue. The first band charged $15 per ticket. The second band charged $45 per ticket. The final band charged $22 per ticket. There were 510 tickets sold for a total of $12,700. If the first band had 40 more audience members than the second, how many tickets were sold for each band? Okay, lots of information there. Let's define our variables here. What are we trying to find? We're trying to figure out how many tickets were sold for each band. Well, there are 3 bands, right? So there are 3 unknowns that we want to find. So let's let X be tickets for first band. Wow, really sloppy handwriting. Let's be Y be the number of tickets for the second band. And let's Z be the number of tickets for the third band. I find it oftentimes helpful to actually write down what the variables are for, so I can always look back and reference and say, okay, what was that again? I would like to challenge you on this video, and I don't know how much you guys have been doing this, but here's my challenge to you. I challenge you to pause the video and see if you can't write all 3 equations on your own. See if you can do that. So go ahead and pause it and see if you can come up with it. When you unpause it, I'm just going to jump right into it. So go ahead. All right, so let's first look at this. We've got $15 for the first band per ticket. The second band is $45 and the final is $22. So I also look at this. This is the total for all 3 bands, and I think about how do we get that number? We need to know how many $15 tickets, how many $45, how many $22 tickets. And I don't necessarily need to use this number right away, but to start to get a feel for it, I might say, well, what if we sold 2 tickets here, 3 tickets there, and 4 tickets there? How would we figure out what the total cost is? Well, that would be 15 times 2 for 2 tickets at $15. That would be 45 times 3, so 3 tickets at $45, plus 22 times 4 for the 4 tickets for the third band, and that gives me my total cost. Okay, so then I think, okay, well, we don't know it's actually 2 here, so let's call that X. And we don't know it's actually 3, let's call this Y. Okay, remember Y is the number of tickets for the second band, and the number of tickets for the third band is Z. So when we take these total number of tickets times the cost for each ticket, that has to give us that $12,700. Okay, so there's one equation. Now how about a second one? Well, how about the 510 tickets sold? Well, if we go back to that last example where we used 2, 3, and 4, what was our total tickets sold? 2 plus 3 plus 4, which would be 9. So this equation has to be X plus Y plus Z has to equal 510. That's our total number of tickets. Okay. Now the last one. First band, 40 more than second. First band had 40 more than the second. So if I take the second band and I add 40, I get the number of tickets for the first band. The number of tickets for the second band plus 40 has to be the number of tickets for the first band because the first band's 40 more. Now I'm actually going to slide that off to the side here because I don't like the way that this is written. We need to write it in our kind of standard form here, don't we? So what I need to do is I need to subtract X on both sides, subtract 40 on both sides, and I get this equation, negative X. We still have a plus Y. Now we don't have any Z's, right? There are no Z's in this equation. If you want to write plus 0, Z, you can, and that has to equal what? We have a negative 40 on the right. Now you might just write it like this. Okay, that's fine as long as you remember in your matrix there's actually 0 Z's. Okay, these are all 1s, right? These are negative ones. Now we're ready to set up our matrix. So, coefficient matrix, 15, 45, 22, 1, 1, 1, negative 1, 1, 0. Okay. Times our variable matrix, x, y, z, equals 12,700, 510, negative 40. Matrix equations is set up. Remember that this is A, this is X, this is B, and we solve for X by taking A inverse times B. So now it's time to grab the calculator. I'm going to go to matrix. Let's go, whoops. We need to edit that matrix. We need to shrink it down to be a 3 by 3. And let me see what that matrix was again. 15, 45, 22, 1, 1, 1, negative 1, 1. Oh, I've goofed up my negative. All right, negative 1, 1, 0. All right, matrix A is ready. Let's edit matrix B. Let's bring that down to a 3 by 1. Numbers for that. Oh, there we go. 12,700. 510, negative 40. Let me just double check. Yep, looks good. I'm going to go back to my home page. Look, I still have A inverse times B from the last video that we made, so I just hit enter. There we go. 150, 110, 250. So 150 tickets for first band. What was it, 210? No, 110. I believe those are the more expensive tickets, right? For the second band. And then 250 for the last band. All right, so we figured out our band problem. Let's go to the next one. This is not really a real world scenario. This is more like a number riddle kind of thing. 3 numbers add to 216. The sum of the first 2 numbers is 112. The third number is 8 less than the first 2 numbers combined. All right, so 3 numbers add to 216. Okay, so let's let X be first, Y be second, Z be the third number. All right, so 3 numbers add to 216. That's a pretty simple equation here. Actually, you know what? I'm going to do the same thing. I'm going to challenge you like I did in the last problem. Pause this video, see if you can write our 3 equations. All right, first equation, 3 numbers add to 216. X plus Y plus Z equals 216. The sum of the first 2 numbers is 112. That would just be X plus Y equals 112. If you want to write your 0Z in, you certainly are welcome to do that. I'm not going to do that on this one though. And the third number is 8 less than the first 2 combined. Now, I know that's going to be a little bit different than our standard form, so I'm going to write that over here. The third number is 8 less than the first 2 combined. So the first 2 combined would be X plus Y. The third number is 8 less than that. So let's see here. If I start this over, I like this word is because it's equal. So the third number, z, is equal 8 less than the first two combined. The first two combined are x plus y, and z is 8 less than the first two combined, so 8 less than x plus y. So we get z equals x plus y minus 8. Now let's get this into standard form by subtracting x and y on both sides. I get the equation negative x minus y plus z equals negative 8. All right. Matrix times. Here we go. We've got 1, 1, 1 across the top. 1, 1. Don't forget your 0. Negative 1, negative 1, 1 times x, y, z equals 216, 112, negative 8. We've got a times x equals b. We know x equals a inverse times b. So let's grab that calculator. Okay, so second matrix, edit matrix A, still a 3 by 3. There we go. Let's go in and let's edit matrix B. 3 by 1. Our numbers are 216. Let's try that again. 112. Negative 8. Second quit. I still have that same thing, so I can just do go to. What's the problem? No inverse matrix exists. What is that about? Why could no matrix inverse exist? Let's go back and let's look at our matrix again. So let's hit quit. Second matrix. Let's make sure I typed it incorrect. 1, 1, 1, 1, 1, 0. Negative 1, negative 1, 1. Well, that worked out. Let me try this. Matrix A, and let me just see if I can just find the inverse. Still says no matrix exists. Let's hit quit. Let's see here. Why could no matrix exist? Well, what else could I try? Well, we could go back and we could try the method that we used before, okay, where we used our augmented matrix, okay, to find it. So let's see if we can set that up. All right, so I just noticed I'm down to 50 seconds here on this video, so I got to ramp up my ponderings here. All right, so what I'm going to do is I'm going to change this matrix from a 3 by 3 to a 3 by 6. And I'm going to put that augmented matrix over here of our identity. 1, 0, 0, 0, 1. Nope, that was in the wrong spot. 0, 1, 0. And let's put a 1 there. Now let's quit out of this and let's go to matrix. 10 seconds left, rats. Sorry guys, I have to finish this up in the next video.